Hello, and welcome to today's discussion on one of the most exciting upcoming lunar missions. Today, we are going to explore the Nova-C IM-2 mission along with the Lunar Trailblazer orbiter. Nova-C IM-2 is Intuitive Machines' second lunar lander mission. The lander nicknamed Athena is a key part of NASA's Commercial Lunar Payload Services program. Intuitive Machines is a privately held aerospace company based in Houston, Texas, specializing in developing lunar landers. Scheduled to launch from Kennedy Space Center aboard the Falcon 9, IM-2 is targeting landing near the lunar South Pole. This area is of great interest because it may contain water, ice, and other in situ resources, an essential consideration for future Artemis missions. The mission is designed not only to demonstrate a safe lunar landing, but to also test technologies that will pave the way for human exploration of the moon.
For me, it's not just demonstrating a technology and you're done. It's, okay, you've demonstrated it, who's going to use it? So for me, the ability to communicate with a rover over long distances to deliver high bandwidth, as well as the MNova hopper from Intuitive Machines that will leverage the LTE system as well. Once we demonstrate this, then people like Axiom that are developing spacesuits can leverage a similar LTE technology for the Artemis mission. So this is where CLIPS and HLS, our robotic lunar landers and our human landing system, all kind of come together in this continuum of tech demos, tech demonstrations, for science, for exploration, and then immediately can help in the astronauts' missions on the lunar surface. And so that, to me, that continuum is very, very exciting.
The heart of the IM-2 mission is NASA's Polar Resources Ice Mining Experiment, or simply Prime 1. It is designed to extract and analyze samples from the lunar surface. This demonstration is a key step towards learning how to both collect and eventually use the moon's native resources. It includes two instruments, the TRIDENT ice drill, designed to bore up to 1 meter into the lunar regolith. However, instead of extracting a full core sample all at once, it collects samples at incremental 10-centimeter sections. This method allows scientists to assess the presence and the concentration of water ice without expending too much energy. Then there is the MSolo mass spectrometer. Once the samples are extracted, the MSolo mass spectrometer will analyze them. Its primary role basically is to measure the water ice content in the collected samples.
Prime 1 stands for Polar Resources Ice Mining Experiment 1. So our goals are to really learn about the regolith, which is the lunar soil in the South Pole region of the moon. And we're going to do that through a variety of ways. Prime is actually made up of two instruments. The first one is the TRIDENT drill. And so that's a drill that's about 1 meter long. And that is going to penetrate the surface and bring samples, or bring actually lunar regolith soil up from depths and place it on the surface. Once that lunar regolith is placed on the surface, there are going to be frozen and trapped gases that will escape, and that's what's going to be measured by the mass spectrometer, which is the second science instrument on there. And so the goal is to really understand what's on the surface and then what's at depth in the lunar surface that we can use as resources. Now, in addition to that, we'll get a lot of other scientific information about how hard it is to drill into the lunar surface and what kind of bearing capacity and all these other sorts of mechanical features that we need to understand in order to live and explore on the lunar surface.
In addition to Prime 1, the IM-2 lander will deploy 3 secondary experiments and technology demonstrations, including the MNova hopper, which is a small autonomous drone that will separate from the lander. Its job is to hop across the lunar surface, exploring areas that are difficult to reach, such as the insides of deep craters, in search of water ice.
So the hopper is basically like a mini lander. And it comes down to the surface and then it hops away. We're going to see how far it will hop away, potentially into a permanently shadowed region on the moon. And so we're going to test to see how cold it is in a PSR, and then
Next, in partnership with Nokia Bell Labs, is the Surface Communication Network that will demonstrate a 4G LTE conductivity by linking the lander and the hopper, establishing a robust high-bandwidth communication on the lunar surface. The fourth payload is provided by Czech company Advocam, known as the Mini-Pix TPX-3 Space, and is designed to monitor lunar radiation. The data collected will be crucial for designing future crewed missions and protecting equipment from cosmic rays. Together, these payloads aim to study lunar resources as well as test new technologies that could support long-term human exploration of the moon. Riding as a secondary payload on the launch is the Lunar Trailblazer orbiter from NASA's Simple X program, weighing approximately 200 kilograms or roughly 441 pounds. Its mission is to map and characterize lunar water, determining whether it exists as a hydroxyl, liquid, or ice, and to measure its abundance and distribution across sunlight and permanently shadowed regions. Additionally, it will monitor how water and related volatiles vary with surface temperature and solar illumination using the Lunar Thermal Mapper, developed by the University of Oxford, offering critical sights into the moon's water cycle and resource potential. After launch, the Lunar Trailblazer will separate from the Falcon 9 and enter a 100-kilometer polar orbit around the moon. From this vantage point, it will continuously scan the lunar surface for water and help identify potential landing sites for future missions. Thank you for listening to this overview, and a special thanks to EarthSky for making this video possible. I'm Dr. Walck, and until next time.
Okay, I am AC Charania, NASA Chief Technologist at NASA headquarters in the Office of Technology Policy and Strategy.
Yes.
Yeah, so my name is Janine Captain. I am the principal investigator for the Prime 1 mission.
My name is Michael Johansson. I'm the flight demonstrations lead for the Game Changing Development Program, and I oversee the development of about 20 payloads or so for various platforms, including those going to the lunar surface.